is now being recorded. So good afternoon, class, and sorry for the disturbing in the timing. Okay, because what happened, I actually forgot. Yesterday I forgot actually one thing in the college itself, so I couldn't actually continue take the year lecture from home itself. So that's why I had to shift the second lecture from second to third, and right now I'm taking your lecture from college. Okay, because we are at alternate days working. Okay. So now we'll continue our discussion, okay, where we stopped yesterday. And now today we'll be starting with numericals about the kinematics of rigid body. Okay. So we'll be talking about ICR. Okay. So at the end of today's session, okay, so what it is expected is that, okay, so I should be able to illustrate different types of motions and should be able to establish the kinematic relations for a rigid body by using the ICR method. Okay, so in this particular module which is there, okay, so about when I'm talking about kinematics of rigid body, okay, so then you will be having predominantly just one question which is there in your paper. Yes, you'll be having just one question, and that will be on the ICR method. Okay, so that is what actually is the primary importance for us. Okay, and today we will be seeing, okay, that by using the ICR method which is there, so how I can find out how I can do the velocity analysis. Okay, then yes, in the previous session when we had discussed about rigid body, when we had discussed about the rigid body, then we had told that, okay, so the rigid body is motion, which is, okay, so predominantly we can have actually three types of motion that we are interested in. The first type of motion, this is about translation. Translation, nothing more than motion along one axis, right? So it can be any one axis, the motion about that just that one axis which is there. So that is my translation. Then I have rotation, right? Then I have firstly I have translation, then I have rotation, then I have combined motion of combined translation and rotation. So when the ICR method which is there is my ICR method that I'm going to use, okay, so that will be using whenever, okay, so I'm having the combined for any particular link of any particular body which is there, I'm having combined translation and rotation. So at that time, I'll be using the ICR method. Okay. So now, okay, so for us, let me take the example for a slider crank mechanism. Okay, and today we'll be seeing that. Okay, if I want to find out the ICR for the slider crank for the connecting. Okay, so this, okay, so you like my example that we saw yesterday. Okay, if I can correlate this along with in the engine's crankshaft, the engine's connected rod has a piston setup that I saw here. So that is actually basically called as a slider crank mechanism. Okay, we call it basically as a slider crank mechanism. So in that one, the connecting rod which is there. Okay, so one end of that, the connecting rod BC which is there. So that is what actually we are interested in, because one end of the connecting rod which is there, okay, that is having a sliding motion only, motion along the x-axis. Whereas the other end, which is the end B, which is there of my connecting rod, that is going to be having only rotational motion, right? So then the locus of this connecting rod at any one instant. Okay, so for now, what difference will be coming here? Now, if the crank, right now I have something known as this angle is known as the crank angle. Okay, so according to my different crank angles. So now suppose if my crank angle which is there, okay, so just for a case of discussion which is there. So now I have the case like my crank angle which is 0 degrees. So what is 0 degrees? Then at that position my crank AB will be like this. Okay, so if when my AB it is there, okay, so when my AB it is like this, in this position, when my AB is going to be in this position, then what will be my center? What should be my instantaneous center then? Can you just try to think? Okay, so यहाँ पे A is here, B is here. So where will C be? Yeah, A is here, B is here. So where will C be? C will be somewhere here, in this region, or C will be in this region? Which region? 1 or 2?
1.
Why do you think so?
So because we have to find the intersection of everything, no? So we will take on the first side.
No, see, not so, not about intersection. See, think about one thing. This length, the length of AB, is it going to change? No. The length of BC, is that going to change? No. So when actually it is my crank angle is going to be 0 degrees, okay. When my crank angle is going to be 0 degrees, then at that time I have the length AB until here. Then the length BC it is starting from here, right? So the length BC which is there, so that will be coming somewhere around here, right? So my piston which is there, that will be at its extreme position. So this position which is there, okay. So generally, in when I actually I actually have I take the subject of internal com IC in the engines also, okay. There, this particular position, okay. So where my crank and my connecting rod, both of them in the same vertical position, okay. So this position which is there, that position I call as that as my top dead center. I call that as my top dead center. So in the same ways like this, okay, so there is one more term which is called as the bottom dead center. Bottom dead center. So when I say that it is bottom dead center, then what happens is my link AB which is there, my link AB it is in this direction. My point B is here. So at that point, then what happens to C? At that point, then C will be somewhere. My link BC which is there. So my link BC will be here, right? My link AB is here, and since the length of the link it is not going to change, right? There's a rigid body. The links which are there, so they are rigid bodies. So my link C is here, that is at the downwardmost position which is there. So at this point, what is my theta here? My theta it is 180 degrees. So that position which is there, when theta is 180 degrees, that position we actually call in our mechanical engineering, this position which is there, we call it as the bottom dead center. This position which is there, where when theta is 0 degrees, when theta is 0 degrees, we call that as top dead center. Okay. So this is just for information. Okay, so this has nothing to do with your thing. Just because, since we are talking about this piston connecting node crankshaft, I thought okay, I can put that word. Okay. So now, as for each of these angles which is there between 0 to 180, so automatically what happens? The position of the crankshaft and of the connecting rod that keeps changing at each instant, right? So that is why I have the instantaneous center of rotation. So the end B, which is that is continuously rotating, the end C, it is continuously sliding. So this instantaneous locus of instantaneous centers which is there. Okay, at some point of time, it may happen that this will be called as the locus of the instantaneous centers. This is called as the locus of the instantaneous centers which is there. Okay, so we may have that also again in the form of maybe a circle. Okay, or maybe a portion of a circle may have. Okay, so that is what about. Now, when I want to, whenever, okay, so my in angular velocity which is there. Okay, so when we have discussed about instantaneous, where the kinematics of rigid body, we came yesterday across the term of angular velocity. Right? What do I mean by angular velocity? Causing the whenever, okay, so the firstly I have the instantaneous center. First term I have my instantaneous center. So what is my instantaneous center? Can we quickly recollect what is an instantaneous center? Quickly.
The locus of the uh, combination of this linear and rotatory motion, which changes with per instant.
Any one point that I can obtain, okay, an imaginary point I can obtain, about which I can say that the entire link which is there, my entire link is rotating about that point. So that point it is called as my instantaneous center. And the speed at which that instantaneous center will be rotating, that speed it is called as the angular velocity. So now when I'm talking about angle for the link BC which is there, okay. So my angular velocity here, since my link C, which is my link C is moving in which direction? My link C, my point C, at the point C, it is moving towards my right, and my crank, which is there, okay, it is moving towards here. So since my omega AB, my angular velocity of AB is in this direction, so what happens? My link B is also in this direction, and link C is also in this direction. So about the I which is there, okay, so if I want to represent angular velocity, what will be the direction? Will it be clockwise or anti-clockwise?
Anti-clockwise.
It has to be anti-clockwise, right? So this will be omega BC. So I have I here. Okay, then I have to find out omega BC. Now, how do I find out the angular velocity? So for that, I know the relation. I have know the relation. The linear velocity which is there, that will be the length of the link VV equal to IB into omega BC. Also, if I know the velocity at B and the length of the link AB IB which is there, okay, so this imaginary length we have to find out, so I can get the angular velocity. Or if since it is for the link B and for the link B and C, so I can have actually two relations for that. Okay, so VC equal to IC into omega BC. So this is something that I have to remember. Okay, for all the questions in my instantaneous ICR method, which is there. Okay, so we'll be using this equation only. So this is something of very much importance. Then now in this particular circle, in this particular case, which is there, okay, so how do I get the length then? To obtain the length, I'll be using sine rule. So can we recollect what is meant by what is sine rule? What does the sine rule say? Can we apply the sine rule for this triangle IBC? Anybody other than Harsh, can you give me the expression? Can you give me the equation for sine rule? Nobody. Okay, what is sine rule telling me? Okay, do not give the expression. What is meant by sine rule then? Okay, fine. So by actually applying sine rule to this triangle IBC, my instantaneous center triangle. Okay, so what I can obtain is that IB divided by sine of angle IB upon the sine of the angle that is opposite at the opposite corner, right? So that angle ICB equal to IC divided by sine of angle IBC equal to CB divided by, so I'll have to erase some more, equal to CB upon sine of angle BIC, because in opposite to CB link CB, the angle it is this. Now this vector, this IB that I have drawn, okay, so what should be the direction for IB? What should be the direction for IC? That is understanding that it is very important for actually solving problems of ICR. So when I have the link, I have the velocity which is VC, then the angular velocity which is there, okay, so the angular velocity, it will be perpendicular to the direction of my plane. So here, what is my direction of the plane? My direction of plane is in this direction. So perpendicular to that plane here. Now I can also extend it in this direction, but we are not. Okay, so the reason I have already explained it to you in the previous lecture. Now here at this end, I am given the velocity vector in this direction. Okay, so since my velocity vector it is in this direction, my velocity vector is perpendicular to link AB. Then my instantaneous center which is there. Okay, so that is again perpendicular to this, so that will be along the line of AB itself. Okay, so and the wherever the both the links which is there, both the perpendiculars, wherever the both of the perpendiculars are intersecting, so that will be my instantaneous center. Okay, so after I'm getting this, okay, so once I'm making, I have to firstly, I have to, when I have one question which is there, so let us start. Let me erase all of them. So now when I have one question which is there, so firstly what I have to do, when I firstly in the graphical method, so I'll be drawing this. Okay, so I'll be making the perpendicular to the one from one end of the link, then for perpendicular from the other end of the link. So wherever the point of intersection of both the links which is there, so that is my instantaneous center. Then I have to find, okay, for then to obtain the length which is there, to obtain the length of the IB and IC, so I'll have to apply sine rule. For sine rule, now I'll be requiring the angles. Now I'll be requiring for the angles means in the triangle IBC. Okay, so in triangle IBC, I'll be requiring angle IBC. Okay, I'll be requiring this angle. Then I'll be requiring ICB. Then I will be requiring BIC. So finding out this, what is tricky in this part is to obtain this angle. Okay, because not all times which is that the angle or the length is directly available. Okay, so I'll have to obtain it. That is what actually is different. Then after obtaining those angles which is there, I can apply sine rule. Apply sine rule, find out the length of the link. Okay, then after finding out the length of the link, next what I can do, I can apply VB equal to IB into omega BC, VC equal to IC into omega BC. So that way I can find out if I in the question, if I'm supposed to find out angular velocity and I'm given VB. So you are using the expression, I can find out angular velocity and omega BC. And after getting omega BC, I can find out velocity of the other end of the link also. Okay, so that is what we'll be seeing in the upcoming problems. Now, in our first question, okay, so it's a simple problem which is here. Okay, so here I have a rod AB which can slide freely along the floor and on the inclined plane. At the instant which is shown in this figure, okay, so the velocity at the end A, it is 1.4 meters per second to the left. Okay, so now at the end A which is there, okay, so my end A that is moving at 1.8 meter, 1.4 meters per second to the left. Okay, so I can mark VA equal to 1.4 meters per second. Then, so if when my link A is moving in this direction, okay, so what happens to link B, the end B? What will be the direction of motion for VB?
Downwards.
Is it directly downwards like this, or is it along the plane?
Along the plane, sir.
It should be along the plane, right? So yeah, what I have drawn, both of them, they are not along the plane. I know that. Okay, so I have a small actually issue with the tablet. Okay, so in this tablet, making straight lines which is there. Okay, so that is always a question. So here I can, okay, so this will be there. This will be my direction for VB. Okay, then I am have to get the angles. Now for the angles which is there, I'm not given any of the angles. I am only given all the lengths. Okay, so from the given lengths which is there, so we'll have to get the angles, and I am supposed to find out the angular velocity of the rod and the velocity of the end B of the rod. Okay, so now we'll see how to proceed. Okay, so firstly what I have to do is that, okay, so for in my first step, okay, so let me mark the VA. Then here, let me mark VB. Now, next step, what I have to do from VA, which is there, okay. Now, from my end A, okay, so from my end A, I am using a scale, okay, it is not regularly that we use scale for drawing, okay, that is also a little bit of an issue here, okay. Because I actually do not like freehand lines in the board. Making with chalk is different, and making with this is different. Okay. Okay, we can assume that, okay, that is exactly perpendicular. Okay, so a small level of assumption should be required. Okay, so now this point of intersection that I have obtained. Okay, so this will be my instantaneous
ICR.
center. Okay, so this will be my instantaneous center. Now I have to, what I have to find out? Now I have to find out these angles, right?
Yes, sir.
Now I have to find out these all. I'll have to require. I know one length. Okay, I know one length as 500 mm. Okay, so 500 mm. Let me rewrite that as 0.5 meters. Okay. Now for that, okay, so to find out these two angles which are there, this will be definitely, this is perpendicular to my plane, right? So if I'm able to find out this angle, then what will be this angle? This angle it will be, if I'm writing this as theta, so then this will be 90 minus theta, right?
Yes, sir.
And here, when I'm talking about at the end B, so this is also again perpendicular. So if I'm finding out this angle, so if I'm marking this angle as say 5, okay, so this angle it will be 90 minus 5, right? And this angle, what about the third angle I? How will I get the angle I?
So 180 minus both of them.
Yes, well, yes. For the angle AIB, which is this, so that will be 180 minus 90 minus theta, then minus 90 minus 5. Yeah. Okay. So that way, okay. So if we are just for this case, okay, since I wrote in terms of equation, so this I'll be getting it as theta plus 5. Okay. So this will be theta plus 5. Okay. So that, but generally for all the cases, do not do like that. Okay. So find out the angles one by one. Okay. So you will be given any one of the angles. For this question, it is not given. Okay. So that's why that is the case. Now, which is that? Now I have to find the angle. So now how can I find out the angle then? Here, okay, so let me make one more small triangle here. Okay, so let me join it here and let me say mark this as D. Okay, so let me mark that as D. So now when I'm considering triangle ABD, okay, so in triangle ABD, now what is given to me? In triangle ABD, I know AB equal to 0.5 meters. Then the length BD, I know that as 0.3 meters, right? That is given to me. And the length AD is not given. I'm given an intermediate point here. So let me take this as E. So DE, which is there, okay. So the length DE, that is given as 0.125 meters. So now, since triangle ABD, it is a right angle triangle, right? So now, can I not apply my sine rule and get the angle? Can I not apply in my right angle triangle, right? So here, according for finding out theta, what will be, what is it? To find out theta, what is it? Opposite
Sir,
upon hypotenuse, right? So
excuse me,
sine
sir.
theta, yes.
Sir, like we are doing here sine rule, we can directly apply that one also, like cos of theta equals to, I mean, sine of theta equals to 300 by 500. Then we will get directly the answer.
Yes, you can do.
It's because
Okay, you
symmetry
are,
is easily.
yes, you can use that. Okay, no issues.
Okay.
Okay, so sine theta equal to 0.3 upon 0.5. So implies the value of theta, which is there. Okay, so I can get the value of theta 36.87 degrees. So now once I'm getting theta, value of theta, then next what is happening? Next I'll be required to find out this angle. I'll be requiring this angle phi. Now how will I get phi then? Now, since, okay, so this is 0.3 meters and this is 0.5 meters, what will this length be? The length AD which is there. Okay, so what will be the length AD then?
500 cos of 36.87 again.
Again, सिंपल सम ऑफ स्क्वायर्स का यूज करो, 3 है और आपको 5 है, बीच में क्या है बाकी? 5 स्क्वायर इक्वल टू 3 स्क्वायर प्लस,
4 आएगा सर।
तो उसके लिए आपको 5 कॉस की जरूरत करने की जरूरत है क्या आपको?
नहीं सर।
नहीं होनी चाहिए।
3 4 5।
ओके, या 3 4 5, यस। Okay, so the length AD, which is that is I am getting the length AD as 0.4 meters. ठीक है. So now if I am looking at the small triangle, okay, so ये small triangle के लिए मुझे जो I know triangle ABE अगर मैं देखा to get angle phi, तो उसमें भी मैं वापस में साइन रूल अप्लाई कर सकता हूँ, बट उसके लिए भी मुझे सब चीजें मुझे अवेलेबल है क्या? नहीं ना. So for that I'll be requiring this angle, right? ये angle, once I'm getting this angle, then this angle it will be 180 minus this angle, right?
Yes sir.
So this angle it will be, what will be this angle then? ये एंगल के लिए मुझे क्या यूज करना पड़ेगा? थीटा है वहां पे यूज नहीं कर सकता, राइट? So let me use that as alpha. Okay, so alpha equal to tan inverse
Tan
of
inverse of
0.3 upon 0.125. कितना है?
so 67.38.
नहीं, तो वो एंगल की भी आपको जरूरत नहीं है अभी. ये छोटा जो है, ओके, सो ट्राइंगल बी, इफ आई लुकिंग एट ट्राइंगल बी डी ई, दैट अ राइट एंगल ट्राइंगल.
Yes sir.
अभी उसमें मुझे ऑपोजिट साइड पता है, मुझे एडजेसेंट साइड पता है. व्हाट इज बी देन? बी इज द हाइपोटेन्यूज, राइट?
Yes sir.
The length AE. Now I want you to observe actually, and observe and understand. ठीक है. So now in the triangle ABE, okay, in triangle ABE, length AB कितना है मुझे? 0.5 मीटर. लेंथ AE कितना है? 0.4
0.4
minus
minus 1.
0.125, correct?
Yes sir.
Then I have to find out the length BE. What is my length BE then? The length BE, it is the hypotenuse of the small triangle, right? So BE equal to under the root of 0.3 square plus 0.125 square, right?
Yes sir.
अब थॉट प्रोसेस को समझने की कोशिश करो. Understand the process that we are doing right now. ठीक है.
Yes.
So 0.4 minus 0.125, that is 0.275 meters. Then 0.3 plus 0.3 square plus 0.125 square, ये कितना आ रहा है बताओ?
So 0.325.
0.325 meters. Now, now in the small triangle ABE, I don't know the angle. I don't know these two angles. Okay, but oh sorry, we have found out one angle, right? We have found out one angle and we know all the three sides, right? हमने एक एंगल निकाला थीटा and we know all the three sides. So apply sine rule to triangle ABE. Okay. So this time in for this particular question, since the angle was not given, I'll have to apply sine rule twice. Okay. So firstly for this triangle to get the angles, then in this triangle, in triangle AIAB to get the length. So applying sine rule to triangle ABE. So I have AB divided by sine of angle AEB, right? So the angle opposite to that ABAEB equal to AE upon sine of angle ABE equal to BE divided by sine of angle BAE, correct?
Yes sir.
So implies, what is my length AB? Length AB is 0.5 divided by sine of angle AEB equal to the length AE I have found out 0.275 divided by sine of angle ABE. Okay, so sine angle ABE equal to BE 0.325 divided by sine of angle BAE. Angle BAE कितना है मुझे? ये थीटा 36.67. तो sin थीटा कितना हो गया मुझे? 0.3 divided by 0.5. So I can I not write that directly as 0.6? मैंने ऑलरेडी कैलकुलेट करके इसका sin थीटा निकाल के रखा है ना यहाँ पे. So from this, okay, so what is my unknown quantity here? यहाँ पे मुझे रिक्वायर्ड क्वांटिटी क्या है? मैं दोनों एंगल निकाल सकता हूँ, लेकिन मुझे कौन से एंगल से मुझे जरूरत है? मुझे एंगल ए बी ई चाहिए ना, विच इज माई फाइव. इम्प्लाइज एंगल ए बी ई विल बी इक्वल टू, इसको मैंने ये किया इन साइन इनवर्स लिया, तो मुझे एंगल कितना आ रहा है बताओ जल्दी से. So angle AB, I am getting it as 30.51 degrees.
Yes, sir.
So angle AB मतलब क्या हो गया मेरा? 5 हो गया ना.
Yes, sir.
So now in triangle IAB, okay, so मुझे ये angles मिल गए. So now next what I can do, I can go to wherever what my real case is. I have my triangle IAB. Okay, so in triangle IAB मुझे length AB कितना है? 0.5 meters, that is given. Then now I have to find out theta plus phi, ये angle हो गया, right? तो वो भी हमको निकल जाएगा. Angle IAB, angle IAB equal to 90 minus 36.87. तो कितना आ रहा है वो 90 minus 36.87? 53.13 degrees. Then angle IBA 90 minus 30.51, that is 59.49 degrees. And angle AIB, okay, so that is the sum of theta and phi, both of them. Okay, so that angle I am getting it as 67.38 degrees. ठीक, ये तीनों का एडिशन मुझे 180 हो रहा है कि चेक करो? 53.13 plus 59.19, yes, तीनों का एडिशन मुझे 180 हो रहा है. So now in triangle IAB, I know all the three angles, I know the one side. So now I can apply sine rule. So I have IA divided by sine of angle IBA divided by sine of 59.49 equal to IB divided by sine of 53.13. IB and ये angle है 90 minus theta. So 90 minus theta is 53.13 equal to AB divided by sine of 67.38. So AB कितना है मुझे? AB का वैल्यू कितना है? Equal to 0.5, right? So implies IA equal to 0.5 into sine 59.49 divided by sine 67.38. आइए बताओ.
0.466.
0.4667 meters. IB 0.4334 meters. So this way, okay, so I'm obtaining the values of IA and IB. Length of the link भी हो गया मुझे. Now what I can apply? Okay. Now मुझे कौन सा velocity दिया है question में? I know the value for VA, right? VA equal to IA into omega
Omega. Okay.
AB equal to 1.4 meters per second. So implies omega AB equal to VA upon IA, right? VA is the velocity, IA is the length of the link. दोनों का नोटेशन अलग अलग देना है. VA ऐसे ही लिखना है, ठीक है. VA का ऐसे मत लिख देना सीधे. मुझे लिखते लिखते वैसे जा रहा है, मुझे लिखते लिखते आई एम ट्राइंग टू डू दैट, बट स्टिल ओके. But make the notation, write the notations very carefully. Okay. So VA divided by 1.4 divided by 0.4667. So what is the value of omega that you get? 2.999, and the value of angular velocity, it is in radians per second. Okay. Angular velocity का unit radians per second है. Angular acceleration का unit क्या है?
Radian per second square.
Radian per second square. And how do you represent angular acceleration? इसका represent उसको कैसे denote करते हैं
Alpha.
angular acceleration? Yes, alpha. Omega angular velocity and alpha angular acceleration. Good. Now, so omega AB, which is there, I have found out as 2.99 radians per second. And उसका direction अभी क्या है? Clockwise है कि anti-clockwise है?
Clockwise है sir.
Right. My link A, which is there, A is moving towards the left, right? VA is towards this direction. So automatically VB is in this direction. So automatically about A, the entire link AB will be rotating in the clockwise direction. Correct. So my omega AB, which is there, okay. So I'll also be showing it as clockwise.
सर पर जैसे ओमेगा ए का जो अपन डायरेक्शन लेते हैं वो तो एक्सिस के परपेंडिकुलर होता है ना, अबोव एक्सिस या बिलो एक्सिस ऐसे करके.
हाँ, तो आपको परपेंडिकुलर है ना. ये VA का डायरेक्शन क्या है? VA के डायरेक्शन के परपेंडिकुलर है ना आपको. VA का आपको प्लेन की तरह है. VA का प्लेन, व्हाट इज द प्लेन ऑफ एक्शन ऑफ VA about this plane, right? About the plane AE, right? तो उसके परपेंडिकुलर तो मैंने लिया है ना.
अच्छा, ये बाहर की तरफ है क्या सर
क्या?
ओमेगा? नहीं, जैसे राइट एंड थंब रूल जो अपन ने पिछले लेक्चर में पढ़ा था ना, प्रीवियस लेक्चर में जो आपने वो स्लाइड में
हाँ हाँ
बताया था,
हाँ.
उसके
हमको
हिसाब से ठीक
हमको
रहेगा.
मुझे इंस्टेंटेनियस सेंटर जो मुझे अभी आप आई में आप उंगली रख के आप रोटेट करो.
यहाँ से डाउनवर्ड आ रहा है.
हाँ हाँ. नाउ हम लोग ने इसके लिए क्या बोला था? मोमेंट के केस में हमने क्या बोला है? हमने जब भी मोमेंट पढ़ा है तो हमने क्या बोला था?
कहीं भी शिफ्ट कर सकते हैं.
हाँ. अभी ये ओमेगा ए बी जो है दैट इज फॉर द एंडलिंग. ओके. एंड नाउ considering the velocities of A and B which is there, so can I not say that about I which is there, the entire link AB it is rotating in clockwise
हाँ.
direction?
यस सर.
So isn't that not satisfying my condition, my the definition of ICR?
सेटिस्फाइंग सर.
That is satisfying, right?
यस
Isn't
सर.
that my final objective?
यस सर.
Okay. So now, okay, we have found out the angular velocity which is there. Now I am supposed to find out the velocity at the link B. So VB equal to IB into again omega AB. Okay. So the length IB we have found out 0.4334 multiplied by 2.999 radians per second. So this is there. Okay. So this will be getting it as 1.3 meters per second. So now I want you to observe that, okay, my velocity at the end A, which is there, my velocity is 1.4 meters per second. Velocity at the end B, that is 1.3 meters per second. So like the velocities are quite similar. Okay, but that is not the case always. Okay. sometimes it may happen that that depends a lot on actually this length. It depends quite a lot on that length. Okay. So sometimes if this length which is there, okay, so if this length which is there, IA, it is very much greater than IB. Okay. Then what happens? My value of VA which is there, VA will be very less, and VB which is there, VB will be very high comparatively. Okay. So we have some more questions cases for that. Okay. So we'll be discussing them in the now it is already 1:20. Okay. So we'll take one more problem. Okay. So quickly we'll do this problem also, and then we'll kind of stop for today. Okay. So using the instantaneous center of rotation method, I am supposed to find out the velocity of the point A in the figure. Now, the collar bead is moving along the vertical rod and the direction is already given as VB is moving upwards at a velocity of 1.5 meters per second. And the link which is there, it is inclined already at 25 degrees. Okay. So now we have a couple of cases here. ये क्वेश्चन में भी मुझे इंपॉर्टेंट क्या है बोलता हूँ मुझे एंगल निकालना है. Okay, so now my plane VB which is there. So VB is moving here. So what will be the for VB? So what will be my angular velocity का मुझे कैसे प्लॉट करना होगा? Which direction I'll be plotting?
Right side
Horizontal
perpendicular,
to left or to right?
horizontal to
Obviously
right
आपको
sir.
your VB is perpendicular moving upward. So obviously your angular velocity it will be horizontal, right? That is actually uh, I can observe that the angular velocity will be because it is perpendicular. The angular velocity will be like this, right? The angular velocity it should be somewhere like this. Then comes then comes the direction. The direction I can make it in either direction, right? But if I'm making towards this direction, will it be intersecting with the velocity from velocity vector from A?
No
It
sir.
won't. So that's why we are taking I'm making along both the directions. Okay. But in the end, what happens? I'll be taking at the
Yes,
point where
right
it is
sir.
intersecting. Okay. So now with respect, now what is my velocity vector for the point A which is there? So what is the direction of the velocity vector of point A?
Upwards,
This
that
is
same
moving
angle.
upwards, so velocity vector which is there. So for A, the velocity vector it will be in this direction, right?
Yes sir.
So what will be? I have to make a perpendicular to this.
Yes sir.
So now this is
ICR
my
one.
instantaneous of ICR
ICR.
I.
ICR.
IAB. Now I have to get the angles. That is my important part. One angle, okay, so I'm given that this is that at this instant this angle is 50 degrees. So and since it is perpendicular, so what will be this angle then?
40.
This angle is 40 degrees. Okay, we know that one thing. Next, I have to find out this angle. Right? I have to obtain that angle also. How do I get that angle? That's a long part which is there in this question. So for that, this length which is there, I'll be extending this here. Okay. So after extending that, I'll be dropping a horizontal from here, so that I'll be completing that right angle triangle. तो ये एंगल मुझे टोटल कितना आया? ये एंगल ऑलरेडी मेरा राइट एंगल ट्राइंगल है.
Sir,
So this angle which is there, okay, so this
50.
angle it should be 50 नहीं 50 तो ऑलरेडी है
नहीं
यहाँ पे
50
आपको
नहीं
ना.
sir.
So 90 minus 50,
Must
okay. So 180 minus 90 minus 50, so that will be 40 degrees. So
40,
ये
40.
total angle जो है मेरा 40 degrees है. Now if this total angle is 40 degrees and this plane is already inclined at 25 degrees to horizontal, so what will be my this particular angle? What will be my this angle? ये इतना portion कितना है? ये इतना जो है, ये portion कितना angle है ये?
20.
40 minus 25, correct? Try to understand. अभी ये
Yes sir, yes sir.
this total
Yes sir.
angle it is 40 and उसमें से already मैंने 25 जो है plane का angle है. So what is this remaining angle? 40 minus 25, right? So 40
Yes
minus
sir.
25 means 15 degrees. Now if the link AB it is at 15 degrees to my plane, the plane is inclined at 25 degrees and AB is inclined at 15 degrees to the plane. तो मेरा ये angle कितना आएगा?
75.
90 minus 15, right? Equal to 75. So what can I write? I can write angle IAB equal to 75 degrees. Then angle IBA is 40 degrees. We got already. What will be this angle then?
180
180
minus 70
minus
plus
75 minus 40. कितना आ रहा है बताओ?
65.
So angle AIB, it is 65 degrees. बस अभी हमको लेंथ के हिसाब से देखना भी मुझे ये ट्राइंगल IAB के लिए मेरे को क्या हो गया? I know one length. I have found out all the three angles. Now it is just a case of mathematics and applying sine rule.
Yes, sir.
Simple. इसमें हमको एक बार बात कैसे करना है, मेथोडोलॉजी हमको समझ में आया, फिर it is just about okay for different types of how do I arrive at this angle? That is what matters. That is what actually makes the different types of questions that are there. So there we have to see that okay, how do I arrive at the angle? That makes actually each of the problem different. So in the previous problem we had a different methodology. Here I have a different methodology. But at the end I have to arrive, I have to get all the angles for the triangle IAB. Correct? So yes. So here, okay, so I have my this angle, it is 75 degrees. This angle, it is 40 degrees. And this we have obtained, it is 65 degrees. Now, since here my VB it is upwards and A it is also moving in this direction. So about the point I which is there, what will be the direction of rotation of IAB? It will be anti-clockwise. So omega AB, which is the angular velocity, that will be anti-clockwise, right? Now anybody, okay, anybody you have a question, okay, how we have got this, how we arrived at this angle? किसी को अगर डाउट है तो आप पूछ सकते हो अभी, बाद में 10 दिन बाद में, 1 महीने बाद में मत पूछना कि सर मेरे को ये समझ नहीं आया, वापस समझाओ करके. Okay. So now I have given the velocity. Okay, so VB I know. Now in triangle IAB, okay, my length AB it is 1.2 meters. Then angle IAB 75 degrees, angle IBA 40 degrees, angle AIB 65 degrees. Now applying sine rule. Okay. So now when I'm applying sine rule, that means IA upon sine of 40 equal to IB upon sine of 75 equal to AB upon sine of 65. So implies IA equal to the length AB is 1.2 into sine 40 upon sine 65. Then IB equal to 1.2 into sine 75 upon sine 65. So can you give me the values quickly?
$1.27. No, sir. Yes, sir. IB equals to 1.278.
I found out, okay, 0.851 meters. So now VB equal to IB into omega AB, right? So what was AB? IB was 1.278 into omega AB, and V value of VB it is 1.5 meters per second, right? So implies I have omega AB equal to 1.5 divided by 1.278. This should be around say 1.1 or 1.2. Omega AB I am getting it as 1.174 radians per second. And this omega which is there, okay, so what is the direction? The direction it is anti-clockwise. Then VA equal to IA into omega AB. So equal to IA was 0.851 into 1.174. So VA, okay, so we are getting it as 0.998, okay, so equivalent to 1 meters per second. Now VA का direction क्या है मुझे? This, right? So in the previous problem also, okay, so at the end I did not do that, okay, so I had to write the direction also. The direction was upwards, right? वो भी मैंने मिस किया, okay.
So downwards the direction.
So my direction of VB downwards, sorry for that. In here, my direction of VB is upwards, so automatically VA will also be upwards. Okay, so VA and nearly वो angle में दिखा दिया. So now I was in this question which is that I was asked to find out okay the velocity of the point A. I was not asked to find out the angular velocity, but I will be requiring the angular velocity, right? बिना angular velocity के मैं directly में निकाल नहीं सकता, right?
Please move to the previous slide.
Okay, so with this problem, okay, so now we'll stop for today. Okay, we have some more problems coming up. We have some more questions coming up. Okay, so we'll take them in the next session. And with that, okay, so we'll conclude the topic of kinematics of rigid body. Okay. Yeah, so you can give your attendance. बिना बोले शुरू कर दिए. Okay, so if you are given the attendance, okay, so then you can leave the meeting. Who all have not submitted the assignment yet? Or first assignment?